like what they're building, dog. Like get up off me, bro. That's fire. This is fire. I'm over here like low key complaining about the language. It's too big, but that's because I'm too far behind. So I love starting days like this, dude. I love starting days like this. Just like let me see what y'all dudes are talking about because you guys are building this stuff and just way ahead of me in every way in technology. So let me learn from y'all. And I'll understand these words someday. I don't know what diffs are, but maybe I'll learn that someday. We'll see. This is so fire, dude. So far. I like waking up like this. Our suggestions for deciding on tool formats are the following. Give the model enough tokens to think before it writes itself into a corner. Give the models enough tokens to think. This is interesting. I wasn't aware we could do that. Keep the format close to what the model has seen naturally occurring in text on the internet. Make sure there's no formatting overhead, such as having to keep an accurate count of thousands of lines of code or string escaping any code it writes. One rule of thumb is to think about how much effort goes into human computer interfaces, HCI, and plan to invest just as much effort in creating a good agent computer interface, ACI. Here are some thoughts on how to do so. Put yourself in the model's shoes. It is obvious how to use this tool based on the description and parameters. Or would you need to think carefully about it? If so, then it's probably also true for the model. A good tool definition often includes example usage, edge cases, impact, input format requirements, and clear boundaries from other tools. How can you change parameter names or descriptions to make things more obvious? Think of this as writing a great doc string for a junior developer on your team. This is especially important when using many similar tools. Test how the model uses your tools. Run many example inputs in our workbench to see what mistakes the model makes. So their workbench might be something to check out. I don't know. Can run tests in workbench. I mean, that's what it says at least. You so cute. You are so cute. Say what up to the fan. Yoke your tools. Change the arguments so that it's harder to make mistakes. Yeah. Why they acting like they working? Why they acting like they working? They don't even put the work in. While building our agent for Sui Bench, we actually spent more time optimizing our tools than the overall prompt. For example, we found the model would make mistakes with tools using relative file paths after the agent had moved out of the root directory. To fix this, we changed the tool to always require absolute file paths, and we found that the model used this method flawlessly. Flawlessly, dude. Yo, big love to them, dude. Big love to Anthropic for dropping that. Some heat, B. That's some heat, dude. That's some heat, dude. Let's get it. Feel like I got some good ideas out there. Let me explain abstraction layers in software development, particularly in the context of AI agents. Abstraction layers explain. Think of an abstraction layer like a stack of building blocks, where each layer hides the complexity of what's below it. Here's a practical example. Bottom layer, raw API calls to Claude. Okay. Framework layer, LangChain. Agent, LLM. What is 2 plus 2? Agent.run. Why too many layers can be problematic. Each layer adds overhead. Harder to debug when things go wrong. Less control over exactly how things work. Performance impacts. Dependency on third-party code. Real-world example. Some framework, agent, memory, tool, LLM. Agent equals agent. LLM equals LLM memory. Tools 1, 2. Chain type, complex chain. Result agent.run task. What's happening inside? Fewer abstraction layers. Direct approach. Okay.